Hello students, I'm Gonzalo from Wake 2D IB and CAIE Online Academy. Today we're going to see how to solve the free response section of the 2018 AP Calculus AB exam. This is divided in several videos, so make sure you watch all of them. In this particular video, I'm going to solve part C and D of exercise 2, which is included in the free response section with calculator of the 2018 AP Calculus AB exam. In this part of the question, in part C, we need to keep using the same function. Remember, we are talking about a particle that is moving along the x-axis with the velocity given by this formula, and we know that the position is -5 at time equals 0. In part C, we need to evaluate these two expressions, these two integrals. Okay, and well, that's probably the easiest part of the exercise. You just need to introduce in the graphic calculator. Remember that you will see something like this, the integral, and then the two boxes to specify the limits of integration, and then you will see a box and then dx. We're using t, but it doesn't matter. Tx, it's just a letter. Then here you will introduce the 0, you introduce here the 3.5, and then here you will introduce the value of the, not the value, like the expression of the velocity, which is this one. This one will go here. And then the calculator will calculate it for you. If you do it with the calculator, what you will get is for the integral from 0 to 3.5 of the velocity, what you will get is 2.844. We'll interpret the meaning later. And then for the second one, what you will get is 3.737. And now it comes to the difficult part of the problem. We need to explain the meaning of each integral in the context of the problem. So this is the integral of the velocity. The velocity from 0 to 3.5, it might have positive values and negative values. We don't know, we didn't find it, but it could be. And it actually is, because these two numbers are different. In this case, what the calculator does is it integrates this formula from 0 to 3.5. But if this formula at that time from 0 to 3.5 has negative values, the calculator will subtract those parts of the integral. So it will be lowering the number. Instead, if we use this one, it means the integral will always take the positive values of the velocity, which means it will never subtract anything. And this is the difference between these two numbers. In this number, in 3.737, the calculator only took the positive values of velocity, but in the other one, it took also the negative values of velocity. That's the meaning of absolute value. Absolute value is just taking the positive values. By the way, absolute value is also something that you can find in the calculator. Right? You can find these two lines. And so what is the meaning in the context of the problem? Well, if you are taking the negative values, it means that if you, let's say you start at this position, then positive velocity, then negative velocity, you go back, and then you continue, and let's say you finish here. So this will be the change in position. Change in position. But on the other hand, if you are taking into account the positive values, it means this line, yeah, this part, when it's going back, it will also be positive, yeah, and then the third one will also be positive. So actually this is the distance, okay, in the total distance traveled by the particle. So this one, the first one, this will give us the change in position, so the displacement, we can call it displacement. And the second one will give us, this one will be the total distance traveled by the particle over the interval 0 to 3.5. So without the absolute value is displacement of the particle, and with the absolute value is the total distance traveled by the particle. And this is the last part of exercise 2. A second particle moves along the x-axis with position given by, and then we have the formula for the position, t squared minus t, also for 0 to 3.5. The question is, at what time t are the two particles moving with the same velocity? Well, the first particle, the velocity is given by the formula, and if we have the position of the second particle, well, what do we do to find the velocity if we have the position? We derivate. Yeah, if we want to find the velocity of particle 2, what we need to do is to find the derivative of the position of particle 2. And the question is, at what time t are the two particles moving with the same velocity? Well, if we want the same velocity, then the velocity of the original particle has to be equal to the derivative of the position of the second particle. Okay, so basically well, this one is something, the derivative of this is something that you can do. So the derivative is going to be 2t minus 1. Okay, and this has to be equal to the velocity. So what you can introduce in your calculator is v, the formula v. Yeah, it's equal to 2t minus 1. You introduce the whole formula, and then you use the solver tool of your calculator. So what you will get is time equals 1.571, and this is the time when the two particles will be moving with the same velocity. Thanks a lot for watching, and please watch the next videos where I will finish the remaining sections of this part of the exam. Also, don't forget to register for free demo on our website www.waketoryonlineacademy.com.